All right, so let's look at number one. We are going to use what is called the grouping method in order to rewrite this in the equivalent form that is factored. So the first thing I want to do is I want to underline the very first two terms. And I want to ask myself what's the most that I can factor out of 2 and 3. And the largest number is 1. That's not helping us at all. But I can take a maximum of 2 x's out of the first two terms. Now I need to figure out what goes inside. So I'm saying to myself in my mind, 1 times what value is 2? I need a total of 3 x's. I put 1 more down. 1 times what value is 3? 3. I need a total of 2 x's. Bless you, I already have those 2 x's. I'm good. Behind here, I'm writing 2x plus 3, and I'm writing a really light question mark. Now, if this is fully factorable, then I will know a value that I can take times 2x and I achieve negative 8x, excuse me. So that would be negative 4. So negative 4 times 2x is negative 8, and I can see that negative 4 times 3 is negative 12. So I have a front half here, and I have a back half here. So the next thing that I'm going to do is that I'm going to look here, and I see they both have the parenthesis 2x plus 3. One time I write down 2x plus 3. In front of the first group is 1x squared. In front of the second group is a minus 4. Now, most students would think that we are fully done here, and although it looks great, we're not fully done. And the reason behind it, and we're going to see this in this homework today, is if you can underline the second parenthesis. This is not fully factored. And the reason is, when I think about perfect squares, 1, 4, 9, 16, 25, that's 1 times 1, 2 times 2, 3 times 3. I can break this down further. 1 breaks into 1 and 1, 4 breaks into 2 and 2, x breaks into x and x, and we can only do this with the difference of squares when each one breaks down and we have subtraction in between. So this second set breaks into 1x's in the front, 2's in the back, one group has addition, one group has subtraction, and then don't forget to bring down the 2x plus 3. This is considered fully factored. It's equivalent to this original expression. In example 2 and 3, we are learning a new method that's called bottoms up. And so the method that you've previously used, make sure all earbuds are out at this time, please, and all cell phones are put away. The method you've previously used absolutely works. So after you do today's work, using the method I'm asking you to do, and you're like, I just really don't care for this, then feel free to go back to the method you previously used. This just may shorten your time by half. Okay, ready? Here we go. We're going to start off with the exact same thing. Notice I have a trinomial, not 4 terms, but 3 terms. And so I'm going to check, is this factorable? 30 times negative 2 is negative 60. So in my mind, I want to come up with 2 values, and I made a mistake on the last in the last group with this. I want to come up with 2 values that are different signs that combine to give us 7. So this is what I'm doing. This is how my mind's working. I'm like, okay, can 1 and 60 give me 7? No. Can 2 and 30 give me 7? No. Can 3 and 20? Nah, that doesn't work. That doesn't work either. Let's try 4 and 15. 4 and 15 does not work. Oh, here we go. 5 and 12. The difference in 5 and 12 is 7. So 5 and 12 work. So 5 and 12 work. They have to be different signs, and the larger of the numbers is positive. So this is the new method. It starts out in the exact same way. You have to be able to correctly choose those integers. Now here's the shortcut. Make 2 parentheses, please. And then the order you put these in doesn't matter as long as you have the correct sign. So I'm going to write x minus 5 and x plus 12. Step 1, choose the correct numbers. I believe I've done that. Step 2, put them into the parentheses. Now here's step 3. Please circle the leading coefficient. That's going to be the value in front of the x squared in this particular trinomial. We're going to take that and we need to write it underneath both the 5 and the 12. So whatever 2 numbers I've selected, we always write it underneath. Now, if you can do math quickly in your head, you don't need to use a calculator, but feel free to use a calculator here. So please do me a favor. Take 5 and divide it by 30. Hit math, fraction, enter, enter, and I can see that 5 divided by 30 reduces to 1/6. Now, if you can do that in your head, that's giving me faster. So I want to rewrite this as x minus 1/6. I'm going to do the same thing. 12 divided by 30, math, fraction, enter, enter. If you can do it in your head, great. If not, we're going to use a calculator to assist us, x plus 2/5. We're down to our very last step. This is called bottoms up. We're not choosing the larger number. We're not choosing the smaller number. We're choosing the bottom number, and we're going to push it up, bottoms up. So take the bottom number and draw an arrow in front. Take the bottom number, draw an arrow in front. This is 6x minus 1 and 5x plus 2. It is fully factored. We're going to go on right now to number 3. Number 3. What multiplies to equal negative 24 and combines to equal negative 5? So again, my mind is going, and if you're wondering how do I select those numbers, I'm taking 24. 1 and 24 doesn't give me 5. 2 and 12 doesn't give me a 5. Ooh, 3 and 8 can give me a 5. 3 and 8 can give me a 5, knowing that they're different signs when the larger number is negative. So my first step is to select the numbers. My second step is to come over here and make my two parentheses, x plus 3 and x minus 8. I want to reiterate, it doesn't matter if the plus 3 goes first or the minus 8 goes first. Then I'm going to circle whatever the leading coefficient is, and underneath the 3 and the 8, I'm going to write that 6. Now, if you can simplify in your mind, it's going to speed it up. If not, you're going to go 3 divided by 6, math fraction, enter, x plus 1/2, and then 8 divided by 6, math fraction, enter, and x minus 4/3. Now, here's the great part. If you ever simplify something, whether it's in your mind or you're using a calculator and you get an integer, like it simplifies to -2 or +3, then you don't have to do the bottoms up. It's like we get to skip a step. Okay, so I still have a fraction I have to do bottoms up. Bottoms up, bottoms up. So I have 2x plus 1 and 3x minus 4. All right, so this unit is all about rational functions. It's taking two polynomials and we're dividing them. And then we're going to learn how to graph them. So what we're doing next, or what we're doing now, is really going to play an integral factoring. Can you correctly graph things? So there's 3 steps to this. So let's write down the steps right now. Step number 1, please write this down, is we're going to factor. And then I'm going to be lazy here. We're going to determine what can x not be. And then we're going to simplify, and we're done. Those are our 3 steps. Factor, determine what x cannot be, and then simplify. That's what 4 through 11 will occur. So let's first talk about what can x not be. Whenever you see a fraction, and if there's ever a variable in the denominator, we have to figure out what would cause the denominator to equal 0. Like for instance, if I substituted in 2 here, 2 minus 2 would equal 0, and we'd be in trouble. Because remember, one of the major math rules we can't break is we can never have a denominator that equals 0. So let's get started with factoring. This is an easier one to do. So you ready? I get started here. I make my little x off to the side. 1 times -10 is -10, and I'm asking myself, what two numbers multiply to equal -10 and combine to equal +3? That would be 5 and 2. I can see it has to be different signs. The 5 is positive and the 2 is negative. All right. So I make my parenthesis, and I write x plus 5 and x minus 2. And then I want to stop you. If we're going to do bottoms up, what number would I have to divide by? Don't do it yet, but what number would I have to divide by for this problem? A 1. How do you see a 1? I don't even see a 1 in the expression in the numerator. This is the number we divide by. It's the leading coefficient. And when you don't see a number, it's a hidden 1. My next question is dividing by 1 necessary? No, because when you divide by 1, you just keep the same value. So for some of you, maybe you want to write divide by 1, but dividing by 1 doesn't change anything. So we don't have to worry about bottoms up whenever the leading coefficient is a 1. When the leading coefficient is a 1, it's like we're doing elementary math, okay? We don't have to worry about bottoms up. So we've got the top part factored. Let's do the bottom part. There's nothing more to do, so let's write it down. Now we're going to go to the second half of this problem, and I'm going to make my x. Now before I start working, notice that the numerator and the denominator of the second part of this problem both have a leading coefficient that's 1. So I'm not going to have to worry about bottoms up because it's going to be pretty simple math. 1 times -3 is -3. I'm asking myself, what two numbers multiply to equal -3 and combine to equal -2? And that would be what? 3 and 1. The 3 would have to be negative. It's the larger of the two numbers. So this multiplies and it combines. So x minus 3 and x plus 1. And then I would look up above and I would say, oh, it's just a 1 for the leading coefficient, the number in front of the x squared. I don't have to worry about dividing by it. I'm good. Let's do the next part. What multiplies to equal positive 5 and combines to give us 6? Same sign and both positive. That would be, what would that be? 5 and 1. They multiply and they add. So x plus 5 and x plus 1. Again, the leading coefficient is 1. That's simple math. Okay, so I have factored everything out if possible. I've done step number 1. The next step is we have to determine at this point, and this plays a factor into when we graph later on, what would cause the denominator to equal 0? Some of you can just do mental math. I want to tell you that. Some of you can just do that. I'm going to take this and set this equal to 0 and solve. I'm going to take this, set it equal to 0 and solve. I'm taking only the denominators and setting them equal to 0 and solve. So I'm going to add 2 to the opposite side. X cannot equal 2. I'm going to subtract 5 to the opposite side. X cannot equal negative 5. I'm going to subtract 1. X cannot equal negative 1. Notice the cannot. X cannot equal negative 1. It cannot equal negative 5. And it cannot equal 2. And you're like, well, why? Because we would break a major math rule if we got any answer of 2, negative 5, or negative 1 if we were actually solving this, if this was set equal to another number. And the reason, again, is because that would cause the denominators to equal 0. We can never have it happen. So I've done step 1, I've done step 2, and now we're on to step 3. Now step 3 is the simplest. You ready? It's called a 1-for-1 rule. I start by looking at this denominator, and I can look at everything on top. It doesn't have to be directly above it. It can be diagonal, but it has to match with something on top. Is there any groups of exactly x minus 2 on top? There is. So then we're going to cancel it out. So when we say cancel out, that's the wrong math terminology. We should say simplify, because they don't just disappear. Really, they turn into a 1. So I'm going to put a 1 on top and on the bottom. Okay, now I go to the next group. Is there any group of x plus 5 on top? There is. So let's cross it out. Really, they turn into a 1. Is there any group of x plus 1? Yep, there's an x plus 1, there's an x plus 1. So I'm on the very last thing. What do I have here? Well, 1 times 1 times 1 is 1, and then I have the group x minus 3. On the bottom, 1 times 1 times 1 is 1. What do you think this simplifies to? Turn to your partner. What does 1 times x minus 3 over 1 simplify to? That's not wrong, but what's another way to write it? Talk to your partner. Act like you have a friend. Go. What's 1 times anything? What's 1 times anything? Itself. So this would be 1x minus 3. Okay, 1x minus 3. Do I need to write divided by 1? Does it change anything when you divide by 1? So there we go. Done. Now, if you wrote, let me go back here. If you wrote this as your final answer, I would not count it wrong. Did everybody hear this? This is not wrong, but this is a better simplified answer. Let's go on to number 5, please. We're going to increase the rigor here. We're going to increase the rigor. Because I'm a fairly sloppy writer, I'm going to grab a separate piece of paper. You do not have to. Why does it appear that the numerator in the first part is easier than these two others when we factor? What makes it easier when we're doing bottoms up? Turn to your partner, go. What makes this easier than these two? Leading coefficient is a 1. All right, here we go. You ready? So I'm going to do a separate piece of paper. You don't have to. It's just because I kind of write sloppy. So I make my x. What multiplies to give me negative 15 and combines to give me negative 2. That tells me they're going to be different signs, and the larger number is negative. So 5 and 3, negative 5 and positive 3. I like this, so I'm going to make sure that we can see there's a separation. So this is going to be x minus 5 and x plus 3. The leading coefficient is a 1, which makes my life easy. I don't even have to worry about bottoms up. I'm good. In the denominator, I have an x plus 2. Now let's go to the next part. Okay, this is going to be a little bit more work. So over here I have what multiplies to equal negative 4 and combines to give me a positive 3. That tells me they're going to be different signs, and the larger the two numbers is going to be positive. Okay, so we're going to have 4 and 1, and it's looking like this. I'm going to write x plus 4 and x minus 1. Now, here's why Mr. McFarland did not like this method, because he said too often he'd have students that would do this, which is awesome, but what they would forget is they would not look back at the leading coefficient, which happens to be 2. So now I write 2 on the bottom. This is me showing my work. Now, if you can do mental math, great, do mental math. If not, you're going to grab the calculator and go 4 divided by 2, math, fraction, enter, enter, and we get a 2. Okay, awesome. Whenever we're able to get an integer, I don't need to worry about bottoms up. It's only when we've simplified and I still have a fraction that I have to do bottoms up. So 1/2 cannot be simplified. I'm still left with a fraction. That means I need to do bottoms up. The bottom number gets pushed up. So in this position, I have x plus 2. I don't have to worry about bottoms up. There's no fraction. And then I have 2x minus 1. With your partner right now, I'd like you to do the denominator. Please do the denominator of the second portion of this problem. All right. So I'm going 2 times -3. 2 times -3 is -6. What two values multiply to give me -6? Okay, they're different signs and combined to give me a +5. Different signs. That's going to be 6 and 1. The larger number is positive. So I'm going to write down x plus 6 and x minus 1. And remember, most students, when they make a mistake, are going to forget that leading coefficient is 2. Now, if you need to use a calculator, then use it. 6 divided by 2 reduces to 3. Whenever you can reduce it, it's no longer a fraction. You don't have to worry about bottoms up. But when I take -1/2 and I reduce it, I still get the 1/2. So this is going to be, this x minus 1/2 is going to be 2x minus 1. At this point, I have completely reduced things into factored form. And now I need to say, what can x not be? So I'm going to set each of these equal to 0, and I'm going to solve. Each of these is set equal to 0, and I'm going to solve. -2, -3, add 1, that's a little bit harder, and divide by 2. Okay, so this tells me x cannot equal -2. X cannot equal -3. X cannot equal +1/2. I factored. I found out what would cause the denominators to equal 0, and now it's time to do 1 for 1. What on top can I simplify on the bottom? So I start with the x, my x plus 2. Is there any x plus 2's? Yes, there is. So 1 for 1, I'm just going to cross it out. It's done. They simplified to 1. Is there any x plus 3's? Oh, yep, there is. X plus 3 and x plus 3. Done. Is there any 2x minus 1's? Yep, and yeah. Remember, every one that looks like it's disappeared is really a 1. So this is 1 times 1 times 1. So I have 1 times x minus 5. And on the bottom, I have 1 times 1 times 1, which is 1. Now, is that wrong? Mathematically, it's not wrong. But even better way to write it would just be x minus 5. So I'm going to start here. And I'm going to push this up so everybody has a better view of it. So I have x plus 1 on top. On the bottom, I'm going to grab my paper so it's not as sloppy. What multiplies to equal 6 combines to equal 5. That would be the same sign, both positive, is going to be a 3 and a 2. Let's make sure. Multiplies and combines. So I'm going to write down x plus 3 and x plus 2. Notice the leading coefficient is a 3. Divide by 3 and divide by 3. Now, I know 3 divided by 3 is 1. If you need to use the calculator for that, that's fine. So on top, I have x plus 1. On the bottom, I have 1 factor of x plus 1. Feel free to use that calculator if that helps you. So 3 divided by 3, we can see it's a 1. I don't have to worry about the bottoms up. Then I have 2 divided by 3. I try to simplify it. It doesn't simplify any further. So I need to do bottoms up. That gives us 3x plus 2. Before I go any further, just curious, how many of you were able to at least get this far? Hands up. Okay. Next up, I'm going to do this top part. What multiplies to equal 12 and combines to equal 7? Multiplies to 12, combines to equal 7. That's going to be 3 and 4. X plus 3 and x plus 4. Remember, the leading coefficient is a 6. I put a 6 underneath, and then I use the calculator in order to simplify, which simplifies to 1/2 and which simplifies to 2/3. Whenever you simplify and you still are left with a fraction, that tells you we have to do bottoms up. So the bottom number is pushed up. So I have 2x plus 1 and 3x plus 2. Okay, I'm going to do the next part. What multiplies to equal -2 and combines to equal -1? Okay, what multiplies equal negative 2 and combines equal negative 1? That's going to be 2 and 1. The larger number is negative. So x minus 2 and x plus 1. Notice the leading coefficient is different than 1, so I need to divide by 2. Now, I know that 2 divided by 2 is simply 1. And whenever I end up with an integer after I simplify, I don't have to worry about bottoms up. Over here, 1/2 cannot be simplified any further. I still have a fraction, so I push up to get 2x plus 1. Now, I purposely did this one to see if I can throw you off. So I've done step 1, I've factored. Step 2 is what can x not equal. So each one of these would be set equal to 0. Does anybody know the shortcut to doing that? We can do that in under 10 seconds. I'm going to teach you the shortcut right now. Now, if you don't understand the shortcut, do the long way. Okay, here's the shortcut. This is what x cannot equal. When there's no number in front, so just a 1, you take the opposite. So what's opposite of positive 1? But when there's a number in front, you still take the opposite of this, so it's negative 2, but you have to throw the number that was in front down below, so negative 2/3. Again, we have no number in front. The opposite is positive 1. We have a number in front, so the opposite of positive 1 is negative 1, but that number in front has to go down below. So x cannot equal negative 1, positive 1, negative 2/3, or negative 1/2. Just curious, if you understood that, raise your hand. If you didn't, that's okay. So maybe about a third of us. If not, set each one of these quantities equal to 0 and solve. So set x plus 1 equal to 0, 3x plus 2 equal to 0. That's ultimately what I just did with the shortcut. Now we're going to go 1 for 1, but I did this on purpose so you can recognize it has to be exactly the same. So do I have any groups of x plus 1 on top? Yes. So 1 for 1. That means if we have 1 on the bottom, we can cancel only 1 on top. Do I have a group of x plus 2? Yep. Or 3x plus 2? 3x plus 2. I have a group of 2x plus 1, 2x plus 1. So on top, don't tell me there's nothing there. Each one of those ones I scratched out, what does it turn into? A 1. 1 times 1 times 1 is 1. 1 times 1 times 1 is 1, and we have an x minus 1 on the bottom. So I have 1 over x minus 1. That is the simplified version of this.